Aloha class. All right, right now we are in the grind days. All right, so I'm trying to help you guys to grind through this and get really, really good at several of the topics that we can expect to see in regards to the free response. And we all know, right, that the free response will help us out in terms of multiple choice. All right, so here we go. Let's go ahead and do these guys together. Okay, so first question, it says to consider, and what we're working on here is separate and integrate, right? All right, so we're going to separate and integrate. So what do? Well, we have a differential equation that we start out with. And sometimes these questions will ask us to fill in a slope field. Right? This particular one says we have a slope field for this given differential equation as shown below. Sketch the solution curve that passes through 0, 2, shling, and 1, 0. All right, now what does it mean to graph it? Well, I just got to trace. So if it goes through 0, 2, that's just straight up horizontal. So that's what that guy would look like right there. It goes straight through y equals 2. Now this other guy, check this out. Well, let's curves. Okay, let's go ahead and go with the flow. It looks like it bottoms out, but then it looks like it comes right back up. Boom. That would be an example of drawing the slope field for this particular curve. Okay, all right, here we go. Let's go to this next page here. All right, next page. Ooh, that's going to do that, guys. So I don't want my pen. I'm going to go back. Let's go ahead and use my mouse. Boom, I'm using this new little cool little thing they've got here. All right, so we're going to make sure we're good. Okay, so now let's get down to the big parts of this problem. All right, so we have the differential equation. This question here is asking me, they're telling me that y equals f of x is the particular solution to the differential equation. And they're telling me that there is an initial condition. They want me to write an equation for the tangent line at x equals 1. It says to use your equation to approximate 0.7. All right, so how do I do this, guy? Well, we all learned from the first couple weeks of AP Calc, whenever it says write an equation of a tangent line, we should go y minus y1 equals m times x minus x1, right? That should be the very first thing we do, you guys. All right, now how the heck do I get an x1 and y1? Spling! Right there. X1 is 1, Y1 is 0. So we're Y minus 0 equals M, X minus 1. Oh, sweet. I am donezo if I can just find out what M is. Well, M means slope. Well, slope means derivative. There's my derivative right there. So M is going to be equal to dy dx when x is 1 and y is 0. So let's do a little work. If I put a 1 in here for x and a 0 in here for y, I get an answer of, and I got my little answer key here to be super duper fast, I get 4/3. So my answer to this is y equals 4/3 times the quantity x minus 1. Spling. Now, I'm looking at my grading here. You would have got 1 point, 2 points actually for getting the slope field correct, the line above and then the curve below. It's a point apiece. For this one here, you would have got 1 point for getting this right here, so that's 3 points now. And then they do ask me to approximate f of 0.7. Well, f of 0.7 approximated would just be equal to 4/3 0.7 minus 1, which that gives me an answer of negative 0.4. Which we easily should be able to do without a calculator, right? That would be negative 0.3. 0.3 is 3/10, the 3 spling, and I get an answer right there. So far that's 4 out of the 9 points that you could have earned for this separate and integrate problem. Whoops, using my wrong thing there. Clear. Okay, I ended up getting back to my old school pen. I want to use this new school one though, because it kind of erases a little bit better, you guys. All right, so I need mouse there, pen here. All right, now here's the big bad boy. C. We got to know what this means. Find what y is equal to. using the differential equation above. This is the separate and integrate, right, given my initial condition. Okay, so how do we do it? Well, we all know step one is we separate. Well, the way I separate this is I've got to divide out this y minus 2 on both sides. And I'm hoping I'm going to have enough room. I'm going to keep the 1/3 x on this side, but I got to separate that dx to the other one. Remember, I just separate, now we integrate, okay? Now, the tough thing about this guy here is I better rewrite that as y minus 2 to the negative 2. Now, you guys, some of us might have to do a little u sub there. But remember, what would I make my u? I would make my u y minus 2. And if my u was y minus 2, the derivative of y minus 2 is just 1. So I don't really need u sub. So it's really just u to the negative 2. Well, u to the negative 2 would be u, which is y minus 2, to the negative 1, but then I have to divide by negative 1. So I'm just going to put a negative out there in front. Remember, that's the antiderivative power rule, right? You guys going backwards, where we add 1 and then we divide by that. Now that's equal to, this one's a little bit easier over here. It'd be 1/3, right? It'd be x, 1 plus 1 is squared, but then I got to divide by that. So I'm going to end up with a 6 on the bottom plus a c. Now, if you remember in class, I have taught you guys many a times that immediately when a c shows up, we find that c. All right, so let's find my c right now. How do I find my c? I use that initial condition. I'm going to put a 1. I'm going to put a 1 in for x, and I'm going to put a 0 in for y. So I get this right here, 0 minus 2 to the negative 1 equals 1/6, 1 squared plus c. Man, my little thing over here is wigging out every time I write. So I get negative 1 over, that would be a negative 2. So that'd be 2 negatives equal a positive equals 1/6 plus c. I'm going to subtract that 1/6. And when I subtract that 1/6, I get this bad boy, which actually gives me 3/6, which gives me 2/6, which is actually 1/3. So 1/3 happens to be, right? 1/3 is my c. Okay, so remember class, once I find out, and I erased this kind of when I paused it here, once I find out my c, I come back up here, right? And I'm going to replace that c with that positive 1/3. Okay, so let's go ahead, this plus 1/3. And then I'm donezo as long as I can get y by itself. Well, here we got to be pretty cool, pretty neat, pretty intuitive. That's a negative 1. So I'm going to rewrite this guy like this. Okay, that's legit, right? I'm going to rewrite this as 1/6 x squared plus 1/3. And this pen is struggling a little bit. All right, so what do we do from here? Well, from here, remember, I've got to get y by itself. So anytime there's a negative out in front, I better get rid of that first. So let's get rid of that negative sign out in front. And if I do that, it makes everything here on the other side. Now, you can make this problem pretty tough, or you can make it nice and easy, Japanesey. And how do I do that? Well, I taught you guys earlier this year that if I'm trying to solve for y and y is in the bottom, I'm just going to flip it. But the rule is if I flip that side, what do I have to do to the other side? I got to flip it. So let's flip it. Now this is going to look really ugly. But guess what? It's right. Ooh, some of you are saying, come on, Mr. T. If I multiply everything by a negative, this dude right here turns into a negative, right? All right. So then to get this problem done, y is equal to 1 over negative 1/6 x squared minus 1/3. That's all in the bottom, and then plus 2. And believe it or not, remember, this problem was worth 5 points. That gets you a 5 out of 5 for this piece. And I don't know about you, but I'm not loving this eraser. So this pen. So the next problem we do, we're going to go back to the old school pen. Okay, guys, watch this. Clear. That was too fast for you. What are you going to do? Well, you know what you're going to do is you're going to go back and rewatch that video again, all right, or that problem. Because what are we doing now? We're going to 2017. And guess what? Boy, oh boy, Back in the day, this 2017 was called the potato problem. And boy, did my students not like this, but let's get it. There were some really funny memes on this dude. Maybe you should look it up. All right, we got a boiled potato. We take it out from a pot and it cools. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. Oh, snap, that sounds like an initial condition. The internal temperature of the potato is greater than 27 degrees for all times t is greater than 0. So it's never going to go below 27. The internal temperature of the potato at time t minutes can be modeled by this differential equation, where h of t is measured in degrees Celsius. And there they go. They very nicely wrote the initial condition as h of 0 equals 91. All right, part A, write an equation of a tangent line. Isn't that like also was on 2018? So I better know when it says write the equation of a tangent line, that better be my first step. And they say to do it at, for h at t equals 0. So if I wanted to, maybe I should make this more pertinent to the problem. And I'm going to make this h minus h1 equals m t minus t1, where t1 is going to be 0. Guess what, though? When t1 is 0, h is 91. So how about that? Spling, spling. Almost done. Sweet. I just got to find m. Well, how do I find m? Well, m is simply the derivative of h, but I've got to find it when t is 0 and h is 91. So I plug that in. What do I get? I get negative 1/4. H is 91 minus 27. Oh, sweet. Look at this. The AP's hooking me up, right? Because it's number 4, which would be non-calculator. And if I do all of that bad boy correctly, I get the answer of, what's my answer there, class? That would be, what is that? That'd be a little negative 16. I feel like I made a little bit of a boo-boo there. No, I did not. So my answer to this guy, I'm going to put in my slope, would be h equals. I'm going to go ahead and go negative 16t plus 91. Boom. That's my equation. And then they want me to go ahead and do h of 3. So what would that mean? Just put a 3 into my equation over here. And I got an answer of, I'm looking at it right here, 43 degrees Celsius. Boom, boom. Guess what? That was worth 3 points. You got a point for the slope, which was negative 16. You got a point for the tangent line, which was negative 16t plus 91. And you got a third point for the h of 3 value, which was 43 degrees Celsius. How about it? Not too bad, right? So back in the day, can you believe they thought this one was tough? You know why they thought this one was tough? Because you had to read. All right, here we go, part B. Okay, now this is the one we always struggle with. So you know what, at home when you guys are doing this, if you really want to get good, pause it right now and see if you can do it on your own. That's what I challenge you guys to do. All right, let's find this guy's second derivative. Now, in order to find the second derivative, I find it very helpful to distribute. Okay, when you don't distribute it, it kind of makes this problem pretty tough. Now, what do I mean by that? A lot of students try product rule and stuff like that. But if I find the second derivative here with respect to t, it would be negative 1/4, right? Because the derivative of negative 1/4 h would just be negative 1/4. But since it's implicitly and with respect to t, I got to add that dh dt, right? I bet you forgot that at home if you tried it on your own. And if you didn't, huge kudos to you. All right. And then the derivative of 27 over 4 would be 0. Now, for this one here, it's very interesting because you have to resubstitute that back in. And guess what happens? Look what happens when I resubstitute that back in. I multiply 2 negatives and I get 1 over 16 h minus 27. Now, did you have to simplify that to get this full credit point for that? Because you got a point if you did that. You wouldn't have to. But watch, I've got to answer the second question now. And they asked me in part A, when I drew that tangent line, okay, when I drew that tangent line, was it an over or an underestimate? Well, let's look at this. The second derivative, what does that tell me about a graph? Well, the second derivative tells me whether or not a graph is concave up or concave down. Now, what's interesting about this is this looks like it's positive as long as h is bigger than 27. What? It says right here, h is always bigger than 27. Well, then that means the second derivative is always positive. Well, if it's always positive, that means it's concave up. And if I have a tangent line, the tangent line for anything concave up will always be under. And so if it's under, that means it's an underestimate, okay, at time t equals 3. And believe it or not, that was just worth a point. Wow, that was just worth a point. So you had to get all of that correct. Normally, when I see this question on tests, old AP questions, it's usually worth at least 2. They usually will give you a point for the second derivative and a point for your reasoning. But here, you just had to be monies. It was only worth a point. So the second derivative had to be correct, and your underestimate had to be correct with the appropriate reason. All right, here we go. Part C for this one. Okay. Oh my gosh. Okay. So they're giving us some brand new dude. Okay. We have an alternate model when T is less than 10. Okay. And it says that the internal temperature of the potato is satisfied by this differential equation. Okay. And they give me an initial condition, which is the same as before. It said find an expression for G of T. And then based on this model, what is the internal temperature of the potato? All right, now there's only 3 parts here, so this is it. All right, so what are they asking me to do here? They say find an expression for G of T. So if they're asking me to find G, we should automatically think separate and integrate, right? Well, how do I separate this guy? And boy, did they struggle this year on this one. But we shouldn't have, right? We're just going to divide this guy on both sides, okay? I'm going to keep the negative out here with the dt. Shame on me, that should be a dg. That's the separate, right? Now we're going to integrate. Now remember, this is like the previous problem we did in 2018, where my u would be g minus 27, right? It'd be u to the 2/3. Now your du would just be 1 dg. Now remember, whenever your derivative is 1, you don't really need to use u sub. Now why am I saying this is a u sub 1? Because it's that guy right there, right? It's not a natural log. Some of you at home maybe would have thought 1 over natural log. No, because it's not linear. Remember, it's got that negative 2/3 as the exponent. So I'm going to treat this just like a u sub. Now, how do I do a u sub? Well, that's just the antiderivative, right, for a power rule. Now, what's the power rule? Well, the power rule says we are going to add 1. And if I add 1 to a negative 2/3, I get a positive 1/3. But I've got to divide by a 1/3, which if I divide by a 1/3, it's like multiplying by the reciprocal. So that's the correct antiderivative. On the other side, it's just negative t plus c. Oh, snap, a c showed up. When a c shows up, what's the rule, class? We find that c, right? So I'm going to come over here and find it. So how do I find it? Well, my initial condition was g is 91 when my t is 0. So let's go ahead and do work. Okay, 0 plus c, 91. Well, that's just going to be 64. Once again, they help out. What's the cube root of 64? It's 4, so I get 12 to be my c. Remember, once I find my c, I come over here and I plug it back in, and then I solve for g. Well, how the heck do I solve this for g? Well, I'm going to come over here. And the first thing I would do is I would divide by tree, and I get negative t plus 12. I know it looks like you want to make that a 4, but don't you dare. Next, I'm going to cube both sides. And remember, it doesn't matter how ugly this answer is. As long as it's right, it's right. And then I'm going to make it fancy, a little g of t, and I'm just going to get rid of that 27. Well, how do I get rid of that 27? It just means I'm going to put a plus 27 on the other side. That dude's donezo. That dude is donezo. But then I do have to answer the final question. And the final question does ask me, what is the approximation, or what is, this would actually be the actual, right? What's g of 3? Well, g of 3 then would be negative 3 plus 12 over 3 cubed plus 27. And the AP helped me out. That's 9 divided by 3. That'd be 27 plus 27, 54 degrees Celsius, which, if I go back to that first answer we did a long time ago, remember it was 43. 43 for part A we said was an underestimate. because the actual temperature is 54. I did use a different function though for that problem. All right, hopefully you're feeling pretty good. I think I've got at least one or two more that I would like to do with you guys. And remember, we're going to have a quiz on this stuff, so make sure you have this perfected before we have a quiz on it. All right, 2016. Well, how about that? 2018, 2017, 2016. All of these questions had separate and integrate. All right, so let's go ahead and look at this. This is number 4. I got it good to go. Oh, and how about this one? This one here has a slope field to start out. Now, do you remember how I told you to do slope fields? You have an X, you have a Y, and then you have your slope. Okay, and I'm going to do it pretty quickly, but you just have to fill in the dots. Okay, so here's where they have dots for these guys. So I'm going to fill those guys in. 0, 0. If you plug a 0, 0 in there, you get 0. Okay, if I plug in a 0, comma 1, let's see, what do I get if I put a 0 in for X and a 1 in for Y? Oh yeah, I get a negative 1. What happens if I put a 0 in for X and a 2 in for Y? I get a negative 4, so it's going to be steeper. So they're going to look for it just to get steeper, okay, class? Now let's go to this next one. If I plug a 2 in for X, but a 0 in for Y, I'm going to get 0 again. All right, well, what if I put a 2 in for X, but a 1 in for Y? I get a 1. What if I put a 2 in for X and a 2 in for Y? I get 4 over 1, so it's going to be steeper. So you would get 2 points for this. They always give a point for the 0 slopes, and then they give another point for the other guys. And all they want to do is see if it's supposed to be steeper, it better be steeper. Because you don't have to show your work for that. You've just got to draw the slope field. All right, part B. Oh, snap. Here it is again. Write the equation of a tangent line. Boy, I hope it's on this year, you guys. It was on for 3 straight years, right? And this is nice and easy, Japanese by now. I really hope you hit pause and see if you can get this right answer on your own. There's my initial condition. So y1 is 3. X1 is 2. Now I just have to find m. How do I find m? Well, m means derivative at 2 comma 3. So I come back here with 2 comma 3, and if I do it all correctly, I get 9 over 1, or 9ers, and so I get my equation to be y equals 9, x minus 2 plus 3. There's your equation of your tangent line. Now this was only worth 2 points, so you got 1 point for doing that, and then they always want you to approximate. So let's approximate, and this is always non-calculator. So some students might struggle, so I will work through this one with you. So that'd be 0.1, which is 1 over 10. So there you go. It's just 9 over 10 plus 3. Boom. Don't even add them together if you don't want to, but that would be 3.9. Hopefully we should be able to figure that out. So you got 1 point for the tangent line, 1 point for the approximation, but now let's get after it, right? Now we have to do the most important part, which is do the separate and integrate, right? And how do I know it? This word particular solution is a dead giveaway. All right, so let's separate. So the y is on one side, the x's on the other. Now my the students this year that butchered this one fell into the trap. 1 over y squared, they thought that antiderivative was a natural log. Remember, it's y to the negative 2. And if it's y to the negative 2, that means it's a antiderivative power rule, which you add 1 and then you divide by that. So I'm going to divide by a negative, which was the same as having a negative on the outside. Now the right-hand side, the x, that is a 1 over something linear, right? My u would be 1 over u being x minus 1. Derivative of x minus 1 is 1 dx. So I don't really need u sub. So it's just the natural log of the absolute value. You can't forget that absolute value of your u, which would be x minus 1 plus c. Now what do? Well, a c came up. And we all know that immediately when a c comes up, what do? Well, we find that bad boy. How do I find it? Well, I use my initial condition. I put a 3 in for y, and since it's y to the negative 1, I'm going to put it on the bottom, and the natural log of 2 minus 1 plus c. Well, that's just the natural log of 1, and the natural log of 1 is 0. So what am I going to do once I find my c? I come back here and I put it into my problem, and then I'm done if I can get y by itself. Now you will struggle with this one unless you rewrite your y as 1 over y. Okay? Now remember, doesn't matter how ugly your final answer is, as long as it's legit. And to do anything to get y by itself in this one, you better first get rid of that negative sign. And when I do that, it flips these guys, right, class? And then what did I teach you? If you can flip the first guy, well, if you flip the first guy, you've got to flip the second one. And boy, does this look ugly. But guess what? 5 out of 5 money buckets. All right, whenever you have a separate and integrate, the last part is always worth 5 points, right? You get a point for separating, you get a point for both antiderivatives, you get a point for finding C, and then you get a point if you can get Y by itself. It's always worth a ton. That's why I'm making this special video so you guys can all dominate it when it comes to AP testing time. All right, oh my gosh, let's do it again. We're having so much fun. Let's get it, buckets, buckets. All right, so here we go. Number 6, boy, toughest one we're doing so far. Now, why is this the toughest one we're doing so far? Well, you know what? If you want to be super duper challenged, go for it. Go for it. Let's get it. Be super duper challenged. If you don't want to be super duper challenged, let's work with it. Or maybe you can unpause it after each little part, but I challenge you to be super duper challenged. All right, we have 0, 1 as my initial condition. Boom, that's that boy there. Oh, and it asked me to draw it. All right, let's just go with the flow, right? Let's go with the flow. Flow. Spling. Let's go on that roller coaster. Spling. Bang. +1. Just go with the flow. All right, that's all you got to do for that one. All right, easy peasy, Japanese. Oh, sweet. The next dude says, find the equation of a tangent line. Well, we all know what to do if it says find the equation of a tangent line. That's just y minus y1 equals mx minus x1. Well, they give me the initial condition, which is a 1 for y1 and a 0 for x. Well, I got to find the slope. Well, how do I find the slope? Well, that's just dy dx when your x is 0 and your 1 is y. Well, that's nice and easy, right? That's 3 minus 1 cosine of 0. Well, cosine of 0 is 1, so that's just a deuce, a Niemann, right? That's just 2. So I get my equation of my tangent line right here, which I'm guessing that was a point. You got a point for that back in the day, but then I've got to approximate, which we're going to dominate this now. That's just 2 times 0.2 plus 1. That's just 1.5, and you got a point for that. All right, that's 3 points. What the what? That was only 3 points so far. 1 point for the slope field, 1 point for the tangent line, 1 point for 1.4. Oh, snap. That means the next dude was worth 6. Whoa, how is the last one worth 6? Well, it says find the particular solution. There must be some curveballs. It must be tough to make it worth 6. Let's find out why, and I'll go through the points with you on this one. Let's separate. Now, if you separate, you got a point. Okay, if you separate, hit pause. Hit pause. See if you can get it on your own. All right, if you hit separate, +1. Booyah. Boy, it got tough right now because this is a 1 over something linear. And we all know at home that if it's 1 over something linear, I can use the natural law. Well, time out, because my u would be 3 minus y. My du would actually be -1 dy. So if I solve for dy, that negative comes over here. And if I want to rewrite that antiderivative, it'd be 1 over u negative with a du, which means that would be a natural log of your u, but you better have a negative on the outside. Now, if you're really good, you can fix it as you're doing it. You can go natural log of the linear, but since there's a derivative of -1, you got to correct it by putting the -1 on the outside. And guess what? If you got to do this side work to do your u sub, you do it because it's worth a point. All right, the antiderivative of cosine, and a lot of you will make this mistake. It's positive sine because the derivative of sine is cosine. Don't make that mistake either, okay? But that was worth a point. That's 3 points already. All right? We all know to find the fourth point, I have to get C right. All right, well, what's C? Let's go ahead and find out what C is. All right, well, C is when I find it, I use my initial condition. So here we go. I'm going to put a 1 in for Y, so it's going to turn into a 2. I'm going to put a 0 in for sine, which is nice because sine of 0 is just 0. So C is equal to the negative natural log of 2 because the absolute value of 2 is 2. So that got me a point right there if I was able to find C correctly. And then remember, I got to plug it back in here. Now things get a little bit tricky because usually the ending is just worth a point. This ending was worth 2 extra points. So how do I get Y by itself? Well, first I get rid of the negative sign, right? When I get rid of the negative sign, it turns into this, flips both of those guys. Next, I got to get rid of this log base E. Remember, the ghetto way of getting rid of log base E is you raise both to there. And then that rule of logs tell me that I end up with just that. Now remember, I've begged you to do this back in the day. If you rewrite it like this, it really means this. Since those are both up there as exponents, you should rewrite it like that, which thus in turn makes e to the log base e of 2 just 2. And it is helpful to do that. Would you necessarily have to do it? No, but it could help out with a multiple choice question. Now remember, how do I get rid of an absolute value? I've got a plus or minus. So believe it or not, that fifth point comes in if you were able to handle that initial condition. And my final answer is you subtract the 3, okay? And then my final step, right, class, is you get rid of the negative, which turns it to a plus 3, flips your plus or minus, whoops, and then you have to pick for the 6 point the plus or the minus. And it easily has to be the minus because if you remember, when you plug in a 0, you got to get a 1 as an answer, not a 3 plus a 2, which would be the 5. So the final answer for this is y equals 3 minus 2e. And once again, doing this step helped me to be able to figure that out at the end. All right. Now, I'm not going to care about these videos being long because all I care about is getting you guys a 4 or 5. That's all I care about. So I was able to find one more that could be very, very, very helpful. So we're going to get done with it right now. All right. It's 2013. And why is this one different? Because it's got an E dude up here. And I can remember the year. And look at this. There's just 2 parts. So the first part was worth 3 points. The second part was worth 6 points, right? So let's go ahead and get this guy done. All right, first guy, write the equation of a tangent line. Man, we should be able to dominate this. Please be on this test this year. Come on, AP, hook us up, right? We're going through a pandemic this year and all that craziness. Can it help us out? All right, now how do we find the slope? Well, remember, the slope means derivative, and we're going to do it at the condition of 1 comma 0. So if I put a 0, sweet, it's e to the 0, which we all know is 1. And then it's just 3 minus 6. I get a negative 3. So you got a point for getting negative 3. You got a point for writing this equation correct. Boom. Come on. This is nice and easy. Japanese. And then you just got to put a 1.2 in. And if you got that right, you got a third point. Let's go. Let's get it. But guess what? Because they made that worth so many points, they made the last piece kind of tough to deal with, right? So that'd be what, negative 6 over 10 or negative 0.6. All right, but that got you 3 points right there. All right, the next piece was worth 6. And I'm not going to break down the points this time, okay, you guys? I don't want this video getting too crazy, so let's be careful. I can remember, yes, I'm that old. I was teaching AP Calc right here at MCHS back in 2013, and I could not believe it, but some of my students did 1 over e to the y as a natural log. No! No! I hope you guys hit pause and see if you guys would have done it. I should have said it first, gosh darn it. But I really hope you guys didn't do a natural log if you did hit pause. And I'm hoping you guys are hitting pause so you can get better and better. But that's just e to the negative y dy, right? Equals 3x squared minus 6x dx. Remember, you get a point for separating. Well, this is really just an e to the u. But if my u is negative y, that means du would be negative 1 dy. So I got to correct that negative. So that is the antiderivative, right? And you would get a point for getting that antiderivative, right? This antiderivative would be x to the third over 3, so the 3's cancel out. And this would be 6x squared, but then I got to divide by 2, so it turns it into a 3, plus c. Okay, yes, you've got to be great at antiderivatives. Now we find our c, right? 1 comma 0. Awesome. Put a 0 in for the y. That's awesome because that's going to become a negative 1. And then I just get a 1 minus 3 plus c. So that means c is equal to, what's that, a negative 2. And I got a negative 1 on the, oh, sweet. I just get a 1, right? I just get a 1 for that. And you would get a point on the AP exam for getting a 1 for your c. But then now, how do I finish this bad boy? And a lot of students struggle with how to finish this off. Well, the common thing here is if there's a negative out in front, I better get rid of the negative. How do I get rid of the negative? It just flips all of those signs. It really does. Boom. That's it. Nice and easy. Jawbone easy. Now, this is like the opposite of when it was a natural log, when it was log base e, right? We took e, we kind of raised both sides, e to both sides. This guy here, you just do the natural log of both sides. And when I do that, it gets rid of it there. And this whole other side turns into a natural log. Now, don't you dare distribute that natural log. It's not a log property. My final answer for this is simply this. That's it, you guys. And that is the correct answer. And remember, you can always check your answers. And I didn't say this earlier, and I apologize. But if I put a 1 in for x, I've got to get a 0 as my answer. Let's check that. Let's put a 1 in for x. The initial condition must be satisfied. Negative 1 cubed, and then you're going to get a plus 3 minus 1. Well, that gives me y equals negative natural log of 1. Well, the natural log of 1 is 0. Sweet, I got it right. All right. Now, what I highly encourage you guys to do is go do even some more, right? Go do your own research. Do more and more AP Calc questions to get better and better and better. So when we have a quiz in class, you dominate it. All right, aloha. Hopefully these videos were good. If I made mistakes, let me know so we can fix them. Good luck. Aloha.